All right, so we're going to move into our next unit, which is going to start similarity. And our first lesson here is going to focus on some of our standard 12, all right, concepts. So now, if you can see, our unit 6 is going to consist of three topics, or excuse me, three standards: ratio and proportion, similarity, and then using properties of similarity. All right, and so this is on page 21. So let's turn to page 22. All right, and we're going to focus on ratio and proportions for this particular lesson. All right, and you can see that that's going to take in two parts of standard 12. 12.1, I can set up and reduce ratios and proportions, and 12.2, I can use properties of proportions to manipulate equations. All right, so now let's get into a little bit of definition, some terminology, and some notation. Okay, so a ratio is just a comparison of two values. And I'm going to put values in parentheses because we can compare any two things, right? The number of boys to girls, right? The number of redheads to everybody else, right? Number of gingers to everybody else, right? So we can compare anything. The number of Broncos fans to the number of other fans, right? So it's just a comparison of any two values, whatever those values are. Okay, so now a proportion is, all right, two equal ratios. All right, so for example, 5 to 10 equals 1/2, right? All right, so a proportion is just when we have those two equal ratios. Now, what you're going to see is that the notation surrounding ratios, all right, has three really kind of common things that you're going to see. So sometimes we use the colon here, and so we might say, all right, 3 to 5, right? Okay. All right, now we might use that same ratio, but we might use 2. So 3 to 5. All right, and we might use a fraction, 3 to 5. So notice we kind of say the same words, 3 to 5, 3 to 5, 3 to 5. Okay, all right, and it means the same thing, but the way it's represented is slightly different. Now, sometimes you might get it in an abstract form, and all that means is that we're going to use variables, right? So A to B, right? A to B, A to B. All right, and then we just say, right, 2. All right, how to say it? We just say it with 2, right? So 3 to 5. So no, it doesn't matter what form it's in, right? Okay, we just say 3 to 5. All right, and here's the other thing about ratios is that the order doesn't matter. It means the same thing. All right, so if I say 5 to 3, all right, that means the same thing as 3 to 5. It just changes which comes first. Right, so I might say there's 3 Broncos fans and there's 5 Packers fans. All right, so that'd be 3 to 5. But I could say there's 5 Broncos fans to 3 Packers fans, so 5 to 3. So it's just a comparison. All right, and so it's not necessarily right or wrong which one comes first. All right, in that comparison. Now the good news is, all right, when we're working to simplify or reduce our ratios, all right, we really just do this like you do a fraction. All right, okay, so to simplify a ratio, we want to find, all right, a GCF. All right, so we want to look at those two numbers, whatever we're comparing, and we want to find a GCF. All right, and then we're just going to divide, all right, the numerator and denominator, I don't know if I spelled that right, all right, by the GCF. All right, okay, and then that's really, I don't think there's a step 3 here. So find your GCF, divide the numerator and denominator by the GCF, and then that's going to put your ratio into lowest terms. All right, now I kind of get to this definition here. A blank is a number that divides both numbers evenly, and that is a factor, right? All right, and really it's a common factor, right? Because it has to not divide both numbers. That's why it's got to be common. And the greatest common factor is the largest number. And that's typically what we want to look for. Although you don't have to know the greatest common factor. It just means that if you pick the greatest common factor first, all right, you're going to get to that simplified version sooner as opposed to later. All right, so when we think about 40 and 50, all right, we think about common factors. We'd have 1, we'd have 2, we have 5, and we have 10, I believe, would be all of our common factors. All right, and so the greatest common factor would be 10. All right, so that would divide that. All right, and so notice if I divide 40 and 50 by 10, I get 4 to 5. Okay, and notice I could divide by any of the factors, but it's just not going to be fully reduced, so I might have to pick another factor and divide and keep going. So when I think about 18 and 24, I have 1, 2, 3, 6, and let's see, I think that might be it. So 1, 2, 3, and 6. All right, and then so once again, you can see that the greatest common factor for this would be 6 here. All right, so once again, just picking the greatest common factor just means you're going to get to that simplified form sooner. All right, but so if you can't find the greatest common factor, just find a factor, divide by that factor, and then just see if you can find another factor once you get smaller numbers. So sometimes that helps because once you get to a smaller set of numbers, right, you can see that another factor a little bit easier. All right, so that takes care of page 22. All right, so here's what I'd like you to do, all right, is we're just going to work the odd side here, all right? And so I want you to pause the video, all right, and I want you to try to simplify 1, 3, and 5, and then turn the video back on, and we'll see how you do. All right, so now, when I look at 25 to 35, my GCF, all right, would be 5. So if I divide, all right, by 5, 25 divided by 5 is 5, and 35 divided by 5 is 7. So my reduced, all right, ratio, let me get it in focus there for you, is 5 to 7. All right, so when I look at 18 to 60, all right, my GCF would be 6. So I want to divide both numbers by 6. All right, so 18 divided by 6 is 3. All right, and then we're going to use our colon here. And then 60 divided by 6 is 10. And notice in both of these, all right, the way we know it's simplified is that if the only common factor is 1. All right, so that's how you tell. All right, so now when I go to 14 to 70, all right, so the GCF would be 7. So you want to divide everything by 7. All right, okay, and actually I don't think this is, so I just saw 7 here. And so notice, all right, that gives me 2 to 10. All right, and so notice I thought the GCF was 7. All right, but notice when I get here, it's like, oh, there's something else that I can divide 2 and 10 by, which is 2. And so that actually gives me 1 to 5. So I believe if I went back, 14 is actually the GCF. So notice that you can pick a factor, right, and you get there, and oh, look, I just have to think about, is there another factor I can divide by? All right, so no big deal. Just always check to make sure that, all right, you have a factor of 1 as your only common factor, and then you're good. Now, what we do when we have extended ratio just means we're going to be comparing more than 2 numbers, but you treat it all the same way. All right. Okay, so this isn't it. When we compare more than 2 numbers, we call it an extended ratio. Kind of gave you the word up here with the title and the section, didn't we? All right. So for example, a triangle has the sides 5, 12, and 13 feet. So we would just say 5 to 12 to 13. Now, typically when we do extended ratios, you're going to see the colon here, okay? All right, that's typically the most common. All right, you won't see this as a fraction, all right, but you typically will see this as the most common, all right, way of writing an extended ratio. Now, the way we reduce an extended ratio is the same way we reduce a regular ratio. The only difference is it's now, instead of being common to 2 numbers, it has to be common to 3 numbers. So if I look at number 7 here, I've got 10, 24, 26. So now I have to find a common factor that goes into all 3 of those numbers. All right, and I'm going to try 2. All right, so I'm going to divide everything by 2, and I get 5 to 12 to 13. And then when I look at this, once again, the common factor for 5, 12, and 13 is 1, so I know it's in lowest terms. All right, so I want you to try number 8 here. So pause the video, reduce that extended ratio, and flip it back on, and let's see how you do. All right, so hopefully, all right, you looked at this and thought, okay, I can divide everything by 20. All right, so 40 divided by 20 is 2, 60 divided by 20 is 3, and 80 divided by 20 is 4. All right, so then that gets us to 2 to 3 to 4. And once again, the GCF for all 3 of these numbers is 1. Therefore, I know it's in lowest terms. All right, so I'll leave the rest for you to finish in a moment. Let's look at a little bit more here. All right, okay, and let's look at some properties, because here's the other thing that's going to happen is that when we have these proportions, all right, there are some equivalent forms we can do by manipulating those proportions. All right, and so here are 3 of, all right, the properties that we're going to use. All right, so if we have our proportion, A over B equals C over D, the reciprocal property says this, is that it is, and this kind of gets back to what I was saying, like it doesn't matter which way we compare first. All right, so if A over B equals C over D, the reciprocal property says it's the same thing as B over A equals D over C. All right, and so I'm going to go back to this example earlier. So let's say we have 3/5 equals 6/10. All right, so 3 to 5 equals 6 to 10. Well, that means the same thing as 5 to 3 equals 10 to 6. All right, so that's the reciprocal property. And so that's basically saying it doesn't matter which one we compare first. All right, but if I do Broncos fans to Packers fans and Broncos fans to Packers fans, that's okay. But here I could do Packers to Broncos and Packers to Broncos, and that means the same thing. Okay, equivalent form. All right, so the extreme means and exchange properties. What this means is we can switch these two guys. All right, okay, so if I could switch A and D here. All right, so this would be that D over B would equal to C over D. All right, and so using my example here, if I had 3 over 5 equals 6 over 10, all right, notice I can switch these two guys. So then that would be 10 over 5 equals 6 over 3. And you can see that that is still equal, right? 10 over 5 is 2, 6 over 3 is 2. All right, it also says I could switch these two if I wanted. All right, I can only pick one pair. I can't, all right? So then notice that would be if I have A over C equals B over D. So if I had 3 over 5 equals 6 over 10, all right, now I want to switch these two guys. So 3 over 6 equals 5 over 10. All right, and you can see that that still gives me something that's equivalent. That's 1/2 equals 1/2. All right, now the cross product property, all right, is really what we're going to use when we start solving, and you've already been using this property for probably for a couple of years when you solved your proportions. But all that means is that we are going to cross multiply. So A times D is going to equal to C times B. All right, and so if I go back to our example here, 3 over 5 equals 6 over 10. All right, notice if I cross multiply, that would be 3 times 10 equals 6 times 5. And so you can see I get 30 equals 30. All right, so the big idea is that we want you to be able to recognize these forms, all right, be able to move in and out of them, all right? So let's look at number 13 here. And I'll do a couple of these with you just to kind of show you. So given our proportion, use one of the properties of proportions and write an equivalent proportion. So notice there's more than one right answer here. All right, so whenever you do this, the biggest thing you want to do is do what I was doing up here is just check and make sure it's equal. All right, because the answer key may not match the property that you used. So for example, I'm going to use the reciprocal property here. So this would be 8 over 6 equals 20 over 15. And then if I were to divide this, all right, and reduce those fractions, I can see if they're equal. All right, so that's a great way to tell if you did, all right, some good work, is that it should work. All right, so if I divide this gets me to 4/3. If I divide this by 5, that gets me to 4/3. So I know, all right, the manipulation that I just did, all right, works because I get to an equivalent version. All right, so now on 14, I'm going to exchange these two guys. And I'm going to get 32 over 40 equals 24 over 30. Now, once again, if this is an okay manipulation, if this is one of our properties, when I reduce both sides, it should be equivalent. So the GCF of 32 and 40 is 8, and that would give me 4/5. The GCF of 24 and 30 is 6, and that would get me to 4/5. So I get to an equivalent statement. So be sure to check your work when you do whatever manipulation you do, all right, especially if it doesn't match the answer key, and then you know you're correct. All right, so what you need to do now is just finish the rest of this lesson, and I will see you next time.